Whoops, spoiler alert. See, that's what I get for preparing. Not totally. Okay. Hi, everyone. My name is Dodds. I'm so excited to be here in Miami. Thank you all so much for being here. I am excited to talk with you about the web's next transition, what we can expect from the web in the coming, well, even now. It's actually started already. I've been talking about this for a couple of years, and lots of my things that I've been talking about have come to pass, so that's exciting. Before we get into what the web's next transition is, though, I would like to invite everybody to please stand up. Stand, please. Thank you. If you're physically able, if you're not, or if you just don't want to, you don't have to. Don't give in to the peer pressure, but please do. Put your arms out in front of you like this and squat down and come up. This is called an air squat. It's exercise. Yeah. So we're going to do 12 of these together. Ready? 1, 2, 3. Oh, you got to count with me. 3, 4, 5. There we go. 6, 7, 8. You're doing so well. 9. Don't you feel good? 11. Come on, Ken, get up here. All right. Stretch up over your head as high as you can, and over to one side, and over to the other. Awesome. Okay, you can sit down. Thank you so much. So this exercise isn't just like some gimmick that I'm doing. It's actually scientifically proven that your brain needs blood. And blood flow comes from moving. And so that's why I make you move, so that your brain can learn and process what we're going to talk about. So even if you don't get anything out of my talk, you got exercise. So ha! So this talk is a journey through my time as through time as a web dev. It's a little forward-looking as well. So and it's only like 25 minutes long. So there's going to be a little bit of hand waviness as far as like what happened in the last 25 years. Yeah, hopefully it gives you a pretty good idea of what the history of the web has been. And yeah, forward-looking, so we're going to be making some predictions about the future and a bit of a game. It's not so forward-looking as to talk about like AI is going to take all of our jobs and whatever. It's just how we're going to be building web apps in the future. So it's not comprehensive, a little bit of hand wavy. And I've written about all of this in a very long blog post, The Web's Next Transition, on Epic Web Dev. That's the thing that I'm working on full time. I basically want to take everything I know about the web and deliver it to you in the form of many workshops, self-paced workshops. So actually, it's very similar to Epic React, which is like take everything I know about React and give it to you. How many of you have gone through Epic React? Awesome. Thank you so much. I really appreciate that. So Epic Web is going to be the next level thing. It's going to be sweet. So let's get started. HTML1 was never standardized. That's kind of interesting. The first standardization was 2.0, and that was in September of 1995, a month before I turned 7. JS came 3 months later, which surprised me because CSS actually came much later than that. I always thought CSS came first. So yeah, take that, CSS. No, just kidding. We love CSS. HTTP wasn't even standardized until after that. So that's fascinating. We had a way to have documents and even script them before we had a standardized way to send them between computers. That's pretty cool. And then XML, HTTP request, wasn't standardized until 2016. I won't tell you how old I was there. You can figure that out. But like, wow, that's pretty interesting. We were using fetch requests before XML HTTP request was standardized. And in fact, the fetch requests, we started talking about that in 2011. We were using XHRs back in like 2006. So there's something that says about our industry. I'll let you decide what. Okay, but since the very beginning, even before we had XHRs, we had the ability to make web applications because we had the two things you needed for a web application: links and forms. So a way to navigate between pages and a way to tell the server new data, like update the server with new data. And through all that, the history of those 25 or more years, we've had a couple different architectures for building websites. MPAs, they weren't called MPAs at the time because it was the only way to build it, so we just called it building websites or apps. Progressively enhanced MPAs, I call this a PESPA. I don't think anybody's ever called it a PESPA before, but we're going to go with that. We'll talk about what that is. And SPAs, this is when we came up with these monikers of MPA versus SPA, because like there's a unique architecture there with a SPA, and we'll look at that as well. And what I'm going to tell you about is the next transition, but no spoilers yet. We'll get to that in a second. The game we're going to play is called Follow the Code. So there's different code that we write to handle different use cases of web apps, and these are the ones we're going to follow. Persistence, that's like your ORM. Routing is taking a URL and finding the right code to call based on that URL. Data fetching is interacting with the persistence layer to get some data and send it to where the user is. Mutation is the same for updating data. And then rendering logic, that's React, of course, and the React that we're writing. And then UI feedback, that's like loading spinners, pending states, and things like that. So let's start with multi-page apps. So a multi-page app, you didn't write any client-side code. Of course, we learned just a second ago, JavaScript was available since the very beginning, but pretty much nobody was really using it for any of this stuff. It was all just back-end stuff. And I should say also that even though I'm talking about this in the past tense, there are still many websites that are built with this architecture. But yeah, everything's happening on the server. So let's look at some of the characteristics of this architecture from the view of user requests. So the document request, the user enters a URL, it goes to our server, which has a routing layer that will call the right data fetching code, which talks to the persistence, and that calls the rendering code that generates HTML and sends that back to the user. All the while, the browser is doing the UI feedback. So that's why anything in gray is code that you don't write that's managed by somebody else. The UI feedback would be the browser. That's just the favicon spinning. Not very useful, but you'll never escape that. We always have to have that, even if it's the first time your user's getting to your page. So it's pretty simple. Then we also have a redirect mutation request. And I am specific about a redirect mutation request because when a user makes a request to your server and you send back a response, if that response is not, so they're making a post request, if that response is not a redirect, then what you'll get is an entry in your history that includes the post request. And so if the user hits the back button, they'll get the confirm resubmission dialog. So that thing that we all hate so much, and you see those little messages that say, don't hit the back button, that problem would not exist if you would simply just redirect instead of return HTML from your post request. So there you go. It's called post redirect get. It was really common back in the day, but still a lot of people didn't do that. It's a knowledge problem. But anyway, the user is going to submit a form. The browser will show some UI feedback in the form of favicon. Routing logic on the server. We'll go to the data mutation logic and talk to the persistence, and then send a redirect response. And everything from there on down is the same as the previous thing. So it's just like another document request. So that's actually pretty simple. There's not a lot to think about there. And that was the biggest pro of this architecture, still is that it's a really, really simple architecture. That's all there is to it, is the document request and a document post, and that's it. Back in the day when it was really popular, that's like the reason everybody did it is because it's the only way you did. But we had a couple of really, really significant drawbacks because the web browser didn't give us everything that we needed and still is lacking in some things. But Una is going to talk about some of the things that the browser is doing to make these less of a problem, which is cool. So full page refresh, not OK. Imagine if you're on Twitter, or if you want Mastodon, that's fine too. And you go to favorite a tweet or a toot. Do they call it favoriting a toot? I don't know. When you press the heart on the toot. If you had to do a full page refresh when you do that, like how many of those things would you favorite? None, because it would be so stupid. I would hate that. Or like on a GitHub issue, and you were to do a reaction, or a Slack message, you do a reaction. Every time you do that, a full page refresh, no thanks. So the applications we're building today wouldn't even be reasonably possible with the web platform with this architecture. And there was a lack of UI feedback control. So you technically could make a spinner work if you wanted to, but it's still, nobody did that, and it's not the simplest thing in the world. So for these reasons, we moved on to the next architecture, progressively enhanced multi-page apps. So what this means basically is we're going to keep our existing MPA, and then we're going to add to it some additional stuff in the client to make the user experience better. It's enhanced. So progressive enhancement basically means have a foundation of a functional app, and then for users with browsers capable of certain things like scripting, we will add features that make the experience better. So let's look at the architecture now. The PESPA document request is the exact same as our regular document request with an MPA, except now we're loading JavaScript. That's the only thing that changed. But now we also get a new capability, and this is a client-side navigation. And so when the user clicks on a link, our code is going to say prevent default. Do not do the full page refresh thing because we're trying to get rid of that. So they're going to click on a link. We're going to route them to a new page. And so there will be routing code on the client that goes into some data fetching code, and that will make an HTTP request. So this, on the server, this is new code that didn't exist before. We have to have an API endpoint that our client can talk to. In fact, all of this stuff that we're looking at, this is all new code, in addition to the MPA code that we had before. Whereas the document request, this is old code. We had that before. So this is all new code. And so the server will have a routing layer. It will talk to the persistence layer, come back, and then we can render on the client. And like I said, all of this is new code. And the previous one, all this is old code. You see we have a rendering box right there. And we have a rendering box right here. And what's interesting is what it renders has to be the same. We'll talk about that some more. But that's really, really important. So the PESPAs also, the progressively enhanced multi-page apps, also gave us an inline mutation request. This is something we couldn't do before. So now we can favorite a tweet and not have to full page refresh. So the user submits a form. We show some UI feedback, or in the case of Twitter, they'll instantly change the heart to red, even though like maybe the tweet's deleted. We don't even know. So that's called optimistic UI. It's amazing, and more people should be doing that. But the data mutation code is going to talk to the server. Server will do the mutation, send it back, and then we render. And again, all of this is new code that we didn't have with our MPA. And that yellow box of rendering is, again, basically a duplicate of what we have for the server render. And then the PESPA redirect mutation request, we still have the capability of doing that. You're on a GitHub new issue thing, you type it in, you hit submit. That's going to redirect you to that issue just created, right? So a user submits a form, data mutation talks to the routing layer in the server, that talks to persistence, comes back. We route to the new page, the new issue we just created. We do some data fetching code to go get who's assigned to it and all the different things that you need to on that end. That talks to the routing layer on the back end again and gets some data, and then it renders. And again, that yellow box is new code that needs to be exactly the same as what you get on the server render. So let's talk about some of the pros. We no longer have refreshes. So that was what we were going for when we went this direction. And we also get UI feedback control. So we solved both of the problems of MPAs. The problem is we're preventing default. We are not as good as browsers at managing what the browser manages. So you have to think about race conditions and form resubmissions, all sorts of things that the browser handles for you that as soon as you say prevent default, you have to start handling, and most of us do not. I submit as evidence my experience on the web for the last 10 years, and yours probably also. So we also have a lot more custom code that we didn't have to write before. And I know that correlation does not imply causation, but I'm pretty sure that the more code that I have, the more bugs I will have. And so, yes, there's a lot more custom code and a lot of duplicate code. And that's the biggest problem of them all. A lot of duplicate code. So imagine GitHub. They've got their Ruby backend that renders the initial page render. So we're on like the GitHub issues page. So we have a template in Ruby for all of these different issue blocks, right, or the comments. And then when I submit a new comment, it's going to render another issue comment. But that template has to be in the client side because we're not doing a full page refresh. So I have a template in the client, in my JavaScript, and I've got a template in my Ruby. And anytime I need to make a change to either one of those, I have to make a change to both, right? And I actually looked at this, and there are a couple of differences in the HTML from what you get from the server to what you get if you're just on the client. So it is a hard problem, and this was an enormous problem for people building for the web, especially when we were moving to PESPAs. Code organization is a tricky thing always, especially when you're working in multiple different languages that need to be in lockstep with each other. And server-client interaction, also a big problem. So for these problems, here's the solution. How about we just delete all of the duplicate code? And that's where spas came from. We just said, all that stuff that we have on the server for server rendering this and the templates that we got over there, let's just delete all that. And we'll keep our endpoints, our REST endpoints or whatever. Eventually, we'll create GraphQL and just have our stuff all client-side heavy. Awesome. So here's what happened when we did that. Our document request got awful. The document request is the worst. So the user enters the URL, goes to get a static file, whether that was pre-generated or not. And of course, the browser showing some UI feedback. And then the browser renders that HTML, which in the early days of spas was literally just like a div that had ID root and a script tag, and that was it. But even now, like a lot of people are shipping sites like that. Or if it's pre-rendered, you're going to have sort of the same thing, but any dynamic stuff is going to be just a loader because it's dynamic. We don't know on the CDN who the user is. So JavaScript loads. We can now show some UI feedback. We come back to our client-side routing area, and often the client-side routing, if we're doing code splitting the way that we should, so we don't have like enormous apps, then now we have to go get some code, go render, and then go get some more code and render, and go get some more code and render. So we get this waterfall effect, and then all of that code is going to have data stuff. So let's go get the data, and then let's also go get the images that data has URLs for. So what we call this is content layout shift, and it's the worst experience. Even if you're building an app that's behind a login screen, so you're like, none of this stuff matters to me at all. I'm pretty sure that the executive who paid like $50 million for your app doesn't want to load up your app and have things pop in all over the place. That loading experience is bad, even behind a login screen. On top of that, maybe they're in China on a bad network connection, and they want their app to be fast, that they paid all this money for. So yes, it doesn't matter, as much for those types of experiences, but I argue that it really does. It really does. So eventually we get things rendered and things are good. This is what most people are doing these days. And when I say that, I'm not saying this is what most of the websites on the web are architected as. I'm saying most of us who are developing web apps are developing them with this architecture. But that's changing. What's interesting is the client-side navigation did not change from a PESPA. So when we went from PESPA to SPA, client-side navigation stayed the same. The inline mutation stayed the same. The redirect mutation stayed the same. So the only thing that changed when we went to SPA architecture is we made the document request way worse. So as far as the user's concerned. What's interesting, though, it wasn't just that. We didn't just do this because we wanted to make the document request worse. We did this because we hated the code duplication, and we wanted to make our developer experience better. And it did. I know that people like to make jokes about how JavaScript fatigue and Webpack configs, but by golly, folks, this is so much better than what we had with PESPAs. Really, it is. So the problem is we still have most of the cons of PESPAs. And now we have a huge bundle size. And now we've got the waterfalls we were talking about. Runtime performance is also a problem. And state management. Here is an enormous problem. And I submit as my evidence the 3,000, no joke, packages you have on NPM when you search for state management. I'm pretty sure that if there are a lot of people trying to solve a problem, it's a pretty big problem. And state management is huge. I would argue that about 30 to 50% of your time in your code is spent solving this problem. And more than 50% of your bugs are probably there too. So this is a big problem. I'm ready for another transition to solve that problem and make the user experience even better. So let's bring back a really good user experience and make our developer experience better too. I'm so ready. I'm screaming at you. Ready, excited for you all to hear about this next transition. And here it is. It's called the PESPA, Progressively Enhanced Single-Page Apps. It sounds like Vespa. How many of you have seen Luca? That is not enough. Go watch Luca, folks. Okay, so this is what a PESPA is. The idea is let's go back to the PEMPA architecture and rethink what was so bad about that. It was the code duplication. So what if we don't duplicate the code and just use the same code on both sides? We share that code. And so here's what the PESPA architecture looks like. The document request looks just like a PESPA. It's just like an MPA, except now we're loading JavaScript. So that's cool, nice and simple. We get the nice user experience there. The client-side navigation, now we have routing that is shared between the client and the server. Our data fetching, also, there's a little bit of code on the client to actually make the fetch request, but most of our data fetching code is on the server, and that communicates with our persistence layer. And then the rendering code, it's on the client, but as the difference here is that yellow box on the document request is the exact same as the yellow box on the client. And that is what solves that PESPA problem. Our inline mutation request also, it actually looks very similar to our client-side request, except first we do the data mutation, and then we revalidate. This is actually very similar to the MPA, where the bottom half is very similar to a document request. We're revalidating the data. And then the redirect mutation request actually looks exactly the same as an inline mutation request. So here's something that's kind of interesting. We can build the Twitter heart button as if it was doing a full page refresh, but it's not. And so we get the simple mental model of an MPA by just thinking every time it's a full page refresh, but we don't have the bad user experience of what that would be. And so we get the simple mental model back from an MPA. That's awesome. I want that. I liked the simple mental model. I just didn't like the UX. So we don't get the full page refresh. And we get UI feedback control. We're emulating the browser, doing a lot better job of making sure we handle race conditions and form resubmissions, things of that nature. And that would be something that you do within whatever framework that you're using. There's no code duplication because it's the exact same code on both sides. We reduce the client-side JavaScript because we can push more stuff on the server. All of our data loading code is going to be on the server. And there are no waterfalls because we're server rendering. And so all the image URLs are right in there. There's no content layout shift that you need to worry about. And no application state management. Because if it's progressively enhanced, that means it starts with a baseline of a functional app. And then we use JavaScript to make the experience better. So if your app is functional without JavaScript, you can't use a client-side state management library if you want that particular characteristic of progressive enhancement. And so therefore, that's just evidence you can't use application state management. Of course, you can with these technologies, but then you lose out on all of these pros. So the cons are interesting because we don't actually know what the problems are going to be with a new technology. We see this over and over again. Somebody releases something new and everybody says it's the next X killer and it's going to be amazing. And then later we find out, oh, like there actually are some trade-offs here. The problem is it's kind of like dating somebody new where you're like, wow, they're amazing and they're the best and I just love them. And then like a couple weeks later, you find out they do have a couple of rough spots. And that's fine because you forgive them for their rough spots, they forgive you for yours, and you can be happy together. Don't look for the perfect person because they probably already found somebody better than you. Just kidding. So here are a couple of things, though. It requires servers. Yeah, so one of the things I loved about the Spa is I could just like put my site on an S3 bucket or on one of the amazing hosts that we have these days and not have to think about servers. 99.9% of the apps that we're building and getting paid to build do require servers at some level. So your organization's already dealing with running code on a server. So I don't really think this is a huge issue, especially with what you get out of that. Server cost, yes, servers do cost money to run, but you can get like 1 million requests on Cloudflare for 15 cents. So like, okay, yeah, you got to put in a credit card, I guess. No, I don't mean to diminish the importance of this, but it really, our compute has gotten really, really good as far as cost is concerned. You do have to think about code that will work on both sides of the server and client, but not all of your code has to run on both sides. You can say, you know what, server doesn't even do a canvas, so I'm not going to try and server render a canvas. There are certainly some things that that you can do only on one side. But it is another thing you have to think about. And we'll definitely discover more things. I'm not blindly just saying, hey, like you should all just use this thing. It doesn't have any problems. There are definitely going to be more problems we discover. So I was one of the co-founders of Remix, so full disclosure there. But I loved Remix before I joined. And Remix is amazing, and it's what got me thinking about the PESPA architecture. But a lot of other frameworks are adopting these things. Even non-JavaScript frameworks are adopting this architecture, and so really validating what Remix has been doing. I want to show you some code before I ramp up here. So in Remix, this is how you would build a route for a product list. So first, we have this loader. This runs only on the server. So you can use private keys. You can talk to a database directly, whatever you need to do. And so whatever you're doing here, you get the request. That's an HTTP fetch request object. So you want to learn how to use this, you go to MDN, not the Remix docs. That is awesome. And then the JSON function there is just a simple utility that returns a response, a web fetch response. So you want to learn what you're supposed to return from a loader, you go to MDN, not the Remix docs. That's cool. So Remix will manage calling this for you and making sure that the data that is in here stays up to date as the user's making changes, which is super cool. That's what gives you the MPA feel. On the client side, sorry, I shouldn't say client side. This is actually, I call this the UI because this renders on the server as well as navigations on the client. But you get your projects, you can map over them and do whatever you do in your React, and it's awesome. And then we have a form, and just a regular old form, except it's a capital F because it's actually a component that will manage the prevent default because we don't want full page refreshes, so we are going to prevent default. But you use it like a regular form. You have inputs, they have names. You can have hidden inputs for like hidden stuff that you don't want the user to see that you want to be submitted. So it's all nice and declarative, much better than our fetch request stuff. Now we have to manage all of this state. It's really, really great to work with. And so that we can determine what the current state of this form submission is by looking at this use navigation. So a form submission is a navigation. And say we're creating a new project, and so it's going to navigate us to the new project page. So while that submission is happening, we can show a pending state, or we can show optimistic UI, or we could do it whatever. And again, all just very nice and declarative. Super awesome to work with. And so while that request is happening, it's going to hit your action. Remix is going to manage calling this for you with a request, a web HTTP fetch request. And you do whatever you want to with it. There's that request.form data. That's a web platform API, not a Remix API. So we can build abstractions on top of the web platform API that work really nicely together because it's all just web stuff. And inside of here, you can do whatever validation you want to, return an error. And in the UI, you can get that error and display that error. It's a really, really nice way to work. I love this. I've been working with this architecture for over 2 years now, and it's been amazing. I have loved working in this architecture. It's drastically simplified the things that I'm building and made my UX way better and made me just a much more productive developer. So I hope that you give this a look. With this, something that I think is cool is that Alex Mitchell was just building away on a Remix app and decided one day, hey, I should just try and see like what are the scores on this. And I'm sure that this wasn't mobile, because mobile is like really, really hard to get that 100 performance score. But without even trying, getting 100, like that's cool. And look at this, authenticated on our most expensive page, no caching, and they still got 100. That's cool. Sign me up. I'm in it on this. This is great. Try that on your app and see how you do. Resources. The last link here is a link to an implementation of the same app with all of these architectures, so you can compare and kind of see where the code is moving and stuff. So give that a look. I have one more thing, another resource here, and that's the Web's Next Transition on Epic Web. That's a blog post of everything that I just talked about. It includes all the graphs and stuff too. And I have one last thing to say to you, and that is, you belong here. Thank you so much.